Okay guys, here we will discuss the electric flux through a closed spherical surface. Suppose we have a spherical surface of radius r and we have a charge q which I consider to be a positive charge at its center. Its radius is r. Now this is a positive surface, so it means that electric field line originate from this surface and diverge in all direction. These are the direction of electric field from this positive charge which is placed at the center of this spherical surface. Now I will consider again the positive surface at the center. We have the radius r of this spherical surface and these are the direction of electric field. I will consider a small area element here. Let's suppose this is the small area element. Its area is dA. Now by definition of electric flux, which is given by the surface integral of E dot dA. And we know that the electric field of a point charge at point P which is at a distance r from this point charge is the electric field of a point charge at a distance r is E is equal to 1 over 4 pi epsilon naught q over r square into r unit vector, where r unit vector gives us the direction of electric field. The direction here is this one, and here the direction is radially outward to the surface. And in spherical polar coordinate system, the area element dA is given by r square sine theta d theta in d phi into r unit vector, where the area element is dA and its direction is radially outward, so r unit vector will also be in the direction of electric field. Now using equation, let's suppose this is equation 1, this is equation 2, and this is equation 3. Now using equations 2 and 3 in equation 1, we have flux through the area element dA will be the surface integral. For E I will put this one, which is 1 over 4 pi epsilon naught q over r square into r unit vector dot, and area element I will replace by this equation, which is r square sine theta d phi into r unit vector. Now I will keep the constant outside of the integral. The constant are q over 4 pi epsilon naught, and we left with the surface integral, which is 1 over r square r unit vector dot r square sine theta d phi. Now this r square cancel with this r square and we have r unit vector here. So I left with q over 4 pi epsilon 0 into the surface integral of sine theta d phi into r cap dot r cap. Now here we have this what we call it, the dot product of these two unit vectors r cap dot r cap, and we know that r cap dot r cap is equal to r magnitude into r cap magnitude into cos of, and the angle between them is 0 because they are the same vector. So these are the unit vectors, so their magnitude will be equal to 1. So here we have 1, and cos 0 is also 1. So the product will also be equal to 1. So this vector is automatically equal to 1. So we have the flux phi, which is equal to q over 4 pi epsilon naught into integral of sine theta d phi. And we know that in a spherical polar coordinate system, we have q over 4 pi epsilon naught 0. We have this double integral. The limits of theta are from 0 to pi, and the limits of phi are from 0 to 2 pi. And we have sine theta d phi. Now we have q over 4 pi epsilon naught 0 epsilon naught, and we have this integral 0 to pi. So here I will write sine theta d theta, because this integral applied only on this theta vector, and we have this integral 0 to pi which is applied on d phi. Now if I solve this integral, we have q over 4 pi epsilon naught, and we have from this I will get minus cos theta, and the limit are from 0 to pi, and from this I will get phi, and the limit are from 0 to 2 pi. Now this is equal to q over 4 pi epsilon naught. From this I will get 2 if I put the limit, and from this I will get 2 pi. So overall this is 4 pi. So we have q over 4 pi epsilon naught and we have 4 pi. Now 4 pi. 4 pi cancel with 4 pi, so the flux through this closed spherical surface is q over epsilon naught. This is the flux through this closed spherical surface, and this is basically Gauss's law. Gauss law. And next we will explain Gauss law in more detail. Now what is Gauss law? Gauss law. This law tells us that the electric flux through any closed surface, the electric flux through any closed surface is equal to 1 over epsilon naught times the total charge enclosed by the closed surface. Mathematically we can write it as the flux through any closed surface is 1 over epsilon naught times the total charge enclosed by the closed surface. Or we can write it as phi is equal to 1 over epsilon naught times the total charge enclosed. This is the mathematical statement of Gauss law. Now we will prove this law. We are going to prove this law. The proof is, suppose we have any arbitrary shaped surface, and let's suppose we have charge q1, q2, q3 up to qn. There are n charges inside this closed surface. Now I will consider a small area element on this surface, and the electric field through this area element is E1 due to charge A1, and its area is dA1. Now by the definition of electric flux, the flux through area element dA1 is d phi 1, which is equal to E1 dot dA1. If I integrate this is phi 1. If I integrate this, I will get phi 1 on this side, and on this side we have the surface integral E1 dot dA1. Now the electric field, this is radius R1. At this point, this is Q1, and electric field at a distance R1 is E1, which is equal to 1 over 4 pi epsilon naught Q1 over R1 square into R1 unit vector. And similarly, the area element dA in spherical polar coordinate system dA1 is given by R1 square sine theta d phi into R1 unit vector. Now using these two equations in above equation, we get phi 1, which is equal to integral over this surface 1 over 4 pi epsilon naught, and we have q1 over R1 square into R1 unit vector dot R1 square sine theta d phi into R1 unit vector. This is an integral similar to the case we discussed in the spherical in the topic before, like the flux to a closed spherical surface. So we keep the constant outside, Q1 over 4 pi epsilon naught, and R1 square cancel with R1 square. So we have this surface integral, and we have sine theta d phi into R1 cap dot R1 cap. If we solve this integral, we get the factor 4 pi. So here we have Q1 over 4 pi epsilon naught into 4 pi. 4 pi cancel with 4 pi. So we left with phi 1, which is equal to Q1 over epsilon naught. Similarly, the flux due to charge Q2 is, which is phi 2, which is equal to Q2 over epsilon naught. And finally we have flux through charge Qn, which is equal to Qn over epsilon naught. Now the total flux is a scalar quantity. So the total flux will be, total flux I will represent it by phi, which is equal to the individual flux, sum of individual flux, phi 1 plus phi 2 plus up to plus phi n. Now putting the value of phi 1, phi 2 and phi n, we get Q1 over epsilon naught plus Q2 over epsilon naught plus up to plus Qn over epsilon naught. So 1 over epsilon naught is common, so I'll keep it outside. We have Q1 plus Q2 up to plus Qn. Or we can write it as, this is the total charge enclosed by this closed surface here, Q1 up to Qn. So we have 1 over epsilon naught times, these are the total charge enclosed by the closed surface. So here I will replace this total charge by Q, this capital Q, and it is enclosed by the closed surface, and this is Gauss Law, which tells us that the total flux through any closed surface is 1 over epsilon naught times the total charge enclosed by the closed surface. Thank you.